Yeah, welcome back to the channel. I just find this question very interesting, and I haven't been making videos for a while. Just wanna tell my friends, yeah, I'm still alive. Okay, so I can see I have a lot of print statement because I haven't coded in a while, and yeah, just wanna make sure my code is running. Do a lot of print statement. So this question is a daily question. It's minimum time to make rope colorful. So you're given the colors. It's a string, and you're just given by the distinct colors. So A, B means there are different colors, and then A is the same color. So let's say, in this example, A, B, A, A, C. So A stands for blue, and B stands for red, and then C is green. So as we see, they're like A means they're consecutive. So this questions generally they just don't want any two consecutive balance to be the same colors as mentioned here, and the the needed time to take out that balloon. So let's say these two balloons are same colors, so we need to take out one of them, right? You can also take out both of them, but it's not necessary. So because we want a minimum time, so Bob can technically remove one of this, and in the given needed time array, we have the corresponding time to remove them. So this one is 3, this one's 4. So in this case, we want to reduce the time, which is the minimum time. So we want to remove the one that takes 3 seconds instead of the 4 seconds. Does it make sense? So it's pretty interesting. When I see this question, I was like, yeah, of course, I can do this as O of n because I only need to pass through it once, right? And then I was thinking about some edge cases, for example, like BB, AA, BB. And since you can like swap this, like you can make it BAB or whatever. So as long as you have two consecutive same colors, you have to remove one of them, right? Let's say you have this BB, you're gonna turn out to be BAB, right? There's no way you can make other things. You can make it to be BA, like BA or AB, but it will take more time. As I said, like technically you can remove all the colors and make it only one color left. Um, so one other example is, let's say you have like BBB and AAA. You can't just remove like the middle B and make it BBAA because it will still make it consecutive. So you want the output to be BA, right? Okay, by the way, this is not valid because it's not a minimum, so I removed that one. Okay, so in this case, what I was thinking is just make a list to put in the consecutive one. So let's say this is by itself, so I don't add it to the list. So um, what I imagine is I have a list, and then it will put whatever that's consecutive the same colors. So in this case, this blue are the same colors, so I'm adding the needed time into it. So this is like one of the lists. So let's say if I have another green at the end, which is like 1 second, so it will be another small list, which 5 and 1. So this is an example if this is green. So as long as we know this, I can start coding it out. So it's a bad naming. I just name it list. Python generally doesn't complain about how you name things, but you should know you have a better way to name it. The current list is let's say if you found the same color, you want to add them to a current list. And then just for simplicity, I will make this to be n equals the length of colors. So for I in range of n, so I want to compare, like, let's say this blue is the same as the next blue. This balloon is the same color as the next balloon. So in the case where you are pointing at the last one, then you can't refer to the next one anymore. So I have a separate case for if I is equals to n minus 1, which is the last index. I have a separate case for this one. Then else is like every other case, right? So when do we add this color into a current list is when the next one is the same as this one, right? So let's say if colors at I is equals to the I plus 1, means the balloon right now is the same color as the next balloon. So I want to add them into the current list. So how do you get it? The time is from the needed time at I. That's it. And then the other case is, let's say you're at the end of this, right? So this blue need to be added. So your current list will have a 3, but your current list also need to have a 4, so they can compare which one take the minimum time to remove, right? So in this case, you also want to care about if I is greater than 0 and it's the same as your previous color, right? So this is the same. So in this case, you can add it to the current list, which is data time at I. So in this case, basically, you're out of the first case. So you only fall in this case when you're at the end of the sequence. So when you're having like A, B, 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 the first A will go into this else, this if case, because the next one's the same, right? The same color. And then this one also fall in the first if case because they're the same colors. The next one is the same colors. So you only fall in this else case when you're at the end of the sequence. So when you're at the end of the sequence means that your current list is fulfilled, right? So if your current list is fulfilled, then you can technically append it to the current list, to the list already. So you can add this current list into the list. So your list will have something like 1, 2, 3 or whatever. Since you already added it, you want to make your list to be empty again. All right. And then the else case is just in case where there's nothing and you just don't want to add anything, or in the case where we miss something. That's why I add the else case here. So if the current list is greater than 0, so let's say in the case where we don't catch anything, actually I should verify this, but maybe someone can verify and tell me if this else case is still needed. You can add this current list, and then when you append it, just make it to be empty. All right, so we need to come back to this if case. So if we're at the last one, so technically the logic is the same. If you're at the last one, you only care if the previous one is the same color. So it's technically just this case, right? So if your colors I minus 1 is equals to your colors I was thinking to make this an end case, but I just realized if I did this an end case, then if the colors is not the same, they will go to this else case and then they'll throw an error because you can find I plus 1. So that's how I do it. And then if they're the same, then you do technically whatever like here, right? You append the needed time. And then at the end, no matter what, right? No matter whatever, you want to append the current list. Why did I say so? So let's say in this case, right? You have your current list to be AA or something. You might miss the case where technically you're fine, I think. So this can be some manipulation, I think. Since we already added here, we technically don't have to take care of the case where everything else is not there. So let's say we only edit when you have the same one from previous one. Let's do this. So how do you get the minimum time is just call something minimum time. Just go through the list and the list. So if we go through the list inside the list, we can technically just add the sum of it and then minus the max of it. So let's say we have the case 3 and 4, right? So we want to add the sum of it and then minus the max of this. The max is just 4. But let's say you have the case where you have A, and then this is like 5, 9, 10, 11. For sure, you want to remove those that are like less, because you need to remove 3 anyways. You can't remove 2 or you can't remove 1. You need to remove until 1 remaining. So you want to just not remove the max time. and then you can return the minimum time. So this is the if case here. All right, let's see what's showing errors. Do you mean needed time? Yeah, but that's what I mean. All right, let's submit and see if this pass. All right, so this is a O of n solution. The runtime is O of n. The space complexity is also O of n. Because clearly, if everything is a, then we have to store everything into the current list and append it to the list. Yep. So I hope this is helpful, and just let me know if you can try and save some redundancy. The comment down below.